Hello, let's talk about the definition of determinants, right? And I will illustrate with this 4 by 4 matrix A. First of all, we only define the determinant for square matrices, okay? So a square matrix is a matrix which has the same number of rows as the number of columns, okay? So in this case we have 4 rows and 4 columns. So it's a 4 by 4 matrix, or a matrix of dimension 4 by 4. The first number is the number of rows, the second is the number of columns. Okay? So this element here, it's A32 because it's in the third row and the second column. Okay? Third row, second column, it's the A32, and that's how we put these indices over all the coefficients of the matrix. Okay, so we only define determinant for square matrices, and the way we do is this beautiful formula here, which you probably don't understand, but it's not too hard. Let me tell you what's going on here. We are gonna do the following. We are gonna take the sum of many terms, okay? Precisely 24 terms, and each one of the terms we are going to do the following. I'm going to go over this first column here, okay, and I will choose, or I don't know, I'll go over this first row here, and I will choose one of these 4 columns here, okay. I can do that in many ways. For instance, let me illustrate, and let's say in this first row, I like the third column, okay? Now I have used the third column, which means in what follows, I can no longer use the third column anymore. I cannot pick this or this element, coefficients anymore, okay? Now I move to my second row. In my second row, I could pick this or this factor here. For no good reason, just to illustrate, let's say I pick this. Now I pick from the 4th column, so which means that in what follows I can no longer use the 4th column. I cannot use the 3rd or the 4th column. When I pick an element here in my 3rd row, I can only choose this or that. Because I cannot use this column, I already use it once. I cannot use this column, I already use it. So I will choose between this and this. Okay, and for no good reason, say I pick this guy here, which means I already used this column. When I go to my last row, I cannot use this column because I already used. I cannot use this column because I already used. I cannot use this column because I already used. Well, I have to take this guy here. Okay, and I multiply all this. This times this times this times this, and that's this guy here. Right? I multiply, and this will be one of our terms in calculating the determinant. Now I have to find out if the sign I will put here in front is a positive or negative. I have to find somehow a process, a systematic way to explain if I have a positive here or just a negative here. Okay? So first thing, sigma is a permutation of the set 1, 2, 3, 4. Why set 1, 3, 4? Because we have 4 by 4. Is the set 1, 2, 3 up to the dimension of your matrix. Okay? If this was a dimension, a matrix of dimension 7, here I would have 1, 2, 3, 4, 5, 6, 7. Okay? So sigma is a permutation. What's a permutation? Good question. What's a permutation? A permutation is a bijective function from this set to itself. Do you know what's a bijective function? It's a function which is injective and surjective at the same time. Okay? It's a function from this set, this is the domain, to this set, so this is the codomain, and the function has an inverse function, if you like. Okay? So a permutation is a function from this set to itself, which has an inverse. It's a bijective function. It's injective and surjective. It just exchange the orders, permutates the orders of the elements somehow. Okay? Now, in this product here, I'll have minus 1 raised to the sign of this particular permutation, and I will calculate the sum over when the permutation belongs to the set S4 of all possible permutations. Okay? So how many permutations I have of 4 elements? 4 factorial. Okay? So in general, you have a set of n elements, you have n factorial bijective functions from this set to itself. So a set with, in this example, I have 4 elements, so I have 4 factorial, 1 times 2 times 3 times 4, it equals 24, so I will have 24 terms, and each term I will have to somehow, through this process here, find if this sign is positive or negative, and multiply this sign by A1 sigma 1, A2 sigma 2, A3 sigma 3, A4 sigma 4. What is sigma 1? What is this sigma 1 here? The sigma 1 here in my example is the 3, right? I have A1 sigma 1, A1 sigma 1. Sigma 1 here for me is 3, right? Sigma 1 is 3. Here, sigma 2, 2 sigma 2, 2 sigma 2. So sigma 2 for me is 4. Sigma 3 is 1. And sigma 4 is 2. So here is one particular function from this set to itself, one permutation. The permutation takes the number 1 into the number 3, the number 2 into the number 4, the number 3 into the number 1, and the number 4 over the number 2. Okay? I will do even a graph here to illustrate that. So I will write 1, 2, 3, 4. Okay, I will write here again 1, 2, 3, 4. This is a diagrammatic device, it's very useful. And then I will use this example. So I know that the number 1 is mapped by the permutation to the number 3. So the number 1 goes to the number 3 here. Just make an arrow, it's easy. 2 goes to 4. Woo! 3 goes to 1. Wow! And 4 goes to 2. 2! So I'm sort of mapping. When you do the mapping, there will be some crossings, right? Just be careful to not to have too many crosses at a single point, right? You can have at most one crossing at a single point. Now let's see how many crosses we actually have. Here we have this crossing, 1, 2, 3, 4. So this diagram has 4 crossings, has all 4 places where the lines are crossing each other. Okay? So that means that for this particular permutation, sign, I probably should say the degree of the permutation. I don't know. Yeah, I think degree is probably better. Instead of sign here. Anyway, the important thing is this is an even number. Okay, and therefore, if it's an even number here, minus 1 to the power, which is an even number, 2, 4, 6, 8, it's going to be positive. So this term here will be preceded by a positive sign in the calculation of the determinant. Okay? So that's how the process of finding out if each one of these terms here, this product here, will have a positive or a negative sign. All right? And you do that for the other 23, and you have your expression for the determinant. This is, I'm illustrating just the sign of one of the terms, but remember the sum has 24 terms, so you have 23 other terms to exercise. For instance, I can do another one here. It's very easy for the A11, A22, A33, and A44. Positive or negative here, it's easy, huh? 1, 2, 3, 4, 1, 2, 3, 4. How many crossings? 0 crossings, right? So minus 1 to the power 0, this is going to be positive as well. Okay? While if I had A12, A21, A34, no, let's do 3, 3, and A4. The 1 would go into 2, the 2 would go into 1. We have a single crossing, right? Just one, so it's negative here, right? Because I have an odd number of crossings, so I have a negative for this term here, a negative sign in front. And off you go, you can calculate all the other ones. Okay? That's the definition of, that's how, what it is, a determinant. And we have lots of properties, exciting properties and interpretation and so on and so forth. But I thought you would like to see the definition, the very definition, how it is that we are defining the determinant. Not only memorizing a bunch of rules, but trying to get some understanding. In some sense, we are calculating measurements, volumes, hypervolumes, when we are calculating determinants, but the interpretation I will leave for another opportunity to explain. This is the definition of determinant. Hope you enjoy. See you next time. Bye bye.